Good evening, guys. Welcome to the session. So this is domain analytics from 360DigiTMG. So this is day 5. We are going to see what is meant by k-means cluster. Okay. So this is the day 5, guys. So we are going to see how to use k-means clustering in robotic analytics. As we have seen in the recent videos, guys, we have seen what is KNN, what is the agenda, what is CRISP-MLQ, and how to sort our data, how to clean our data, what are the things we have, right? So we have seen the data science mind map of 360DigiTMG. So I'm going to show you the mind map once more for the recap. Okay. So before going to the mind map, we have seen what is meant by CRISP-MLQ. So CRISP-MLQ is nothing but cross-industry standard process for machine learning quality assurance, right? So in day 5, we are going to see how we are going to use this k-means clustering for robotics analytics. Okay, so you can see k-means clustering. The name itself says unsupervised learning. Okay, the name itself says unsupervised learning, right? So k-means clustering. So in KNN, we have seen what is meant by supervised learning, right? So in k-means clustering, in this unsupervised learning, what is the difference between both? So in supervised learning, it's a labeled data, and unsupervised learning, it's unlabeled data. In supervised learning, we get both input and output. In unsupervised learning, we're gonna get only the output. Okay. So today's concept is all about unsupervised learning, that also in k-means cluster. Okay. So let's move ahead, guys. So we are going to see how we are going to implement this k-means clustering and what are the practical and technical part we should know before applying k-means clustering. Okay. So moving on, we are going to see project management methodology, the CRISP-MLQ. So as I said, guys, what is meant by this project management methodology? It is nothing but standard form to complete the project, right? Standard form to complete the project. Okay, this is what we mean by project management methodology. So we have seen what are the steps involved, what are the 6 phases that make sure to complete a standard project. Okay, so the 6 phases for this project management methodology are business and data understanding, data preparation, model building, model evaluation, deployment, monitoring and maintenance. Okay, these are the 6 things, guys, which are required to complete the project in standard form. The first one is business and data understanding, and we have data preparation, we have model building, we have tuning, we have model evaluation, we have deployment, we have monitoring and maintenance. Okay, so what is this business and data understanding? So we are going to collect the data and we are going to understand it before implementing it. Okay, and after that we are going to use data preparation. Okay, so let me show you the mind map for you, so it'll be easy for you to understand, guys. So in case if you want to understand it clearly, you can go to the web and you can always search data science mind map. Okay, data science, you can see data science mind map 360DigiTMG. So click on that and you can go what all the data preparation things you can see. Okay, not only data science, guys, you get all kind of mind map blocks which are updated every time. Okay, we get the informations which are recently. Okay, business understanding. See, guys, business and data understanding, these are the things you should always see up. You should see record business objective, record business constraint, and the success criteria for that. So if you're going to apply to any business, let me say, so what is success criteria for that? Okay, and it is recommended to write objectives and constraint using 2 or 3 words. So if you are going to describe any objective or constraint, it should be using 2 or 3 words. Also, it is recommended to use the optimization terms, minimize and maximize this. The optimization terms are nothing but minimize and maximize. And next, we're going to see the project charter. So what is this project charter? Project charter is nothing but first document to get signed. Okay, and it contains highly confidential details which is signed by the project sponsor. Okay, so this is what is meant by this, guys. We're going to record business objective, record business constraint, and we're going to see what is the success criteria. Okay, these all things we can see, guys, for the business understanding and data understanding. So what are data types? Is it continuous data? Is it interval data? Right? Is it quantitative, qualitative? Qualitative is nothing but which cannot be measured. Quantitative, which can be measured. Structured versus semi-structured, unstructured data. Structured data, which is the form of labels and columns. Semi-structured data, which are not in the table formats like images and videos. Unstructured data, which cannot be converted to what we say structured data. Big data versus non-big data, when we call 4Vs: velocity, veracity, and variety. See, you can see volume, velocity, variety, and veracity, right? And the non-big data, cross-sectional versus time series, is nothing but which has time and date. Time series which has only time. Longitudinal, combination of both cross and time. Okay, balance versus imbalance of data. We know what is meant by this balance versus imbalance of data. 70 to 30. If it is balanced data, rare events. Offline versus live streaming, guys. See, offline is nothing but very good the recorded videos. Live means the live streaming, guys. For example, you can see the YouTube. Now you can go and search. You can see the deployment part by Baradeep Deep Research. So you can go and watch the videos. That is live data. And if the session is done, that is called as offline data. Okay. So these are data types. And I said about data preparation. If you click on data preparation, you can see what other types. So how we are going to clean the data. So what are the types we have? We have typecasting, converting one data type to another data type. We're going to handle duplicates, outlier analysis treatment, zero and non-zero variance, missing values, discretization, transformation, and many more, standardization. Okay. So these are data cleansing and exploratory data analysis. We have 4-moment business decisions, right? First moment business decision, second moment measure of central tendency, measure of dispersion, and third moment business decision, skewness, kurtosis, and graphical representation. These are EDA guys. Okay. Till now, we have seen how this data works and what all the steps are involved. Okay. So moving back to my data, you can see unsupervised learning. Okay. So unsupervised learning, we're going to see what is meant by unsupervised learning. Okay. So what is this unsupervised learning is? So unsupervised learning is a machine learning technique in which models are not supervised using a training data set, which gives only the output. Okay. Unsupervised learning. Instead of model themselves find the hidden patterns. Okay. Where we can say it's gonna find what all the concepts is required. Okay. And it is also known as unsupervised machine learning algorithm. Okay. Don't get confused. This unsupervised learning and unsupervised machine learning, both are same, guys. We're going to start machine learning there. It uses machine learning, guys. Unsupervised learning uses machine learning algorithms to analyze and clusters unlabeled data. Okay. It's going to use machine learning algorithms to analyze and cluster unlabeled data sets. These algorithms always discover hidden patterns or data groupings without the need of human intervention. Okay. In supervised learning, the human interference is must find any hidden data. But here we don't need any human interference. Okay. So what is the use of this unsupervised learning? So unsupervised learning is very helpful, guys, for data science teams that don't know what they're looking for in data. It can be used to search for unknown similarities and differences in data and create corresponding groups. Okay. For example, let me say user categorization means let me say the categorization by social media activity. So what is going to see? Okay, means this categorization by the social media activities. Okay. So why this machine learning is unsupervised learning is very important in machine learning. So unsupervised learning is helpful for data science teams, okay, that don't know what they're looking for. It, as I said, it can be used to search unknown similarities because it's going to find hidden patterns. Okay. The goal of unsupervised learning is to find the underlying structure of the data set, group that data according to similarities, and represent data set in compressed format. Okay. The resultant groups clusters will have low variance. Of course, if unsupervised learning is going to give only the data, is not the output data, is based on labeled data. The resultant groups or clusters will have a low variance of the timelines. Okay. So instead of this hidden patterns, the insights, the unsupervised learning is gonna have human interference. Okay. So this is all about unsupervised learning, guys. And you can see some of the popular unsupervised learning methods. Okay, so we have K-means question, K nearest neighbors, hierarchical clustering, anomaly detection, neural networks, principal component analysis, independent, a priori, and we have singular value decomposition is nothing but SVD, guys. Okay, so these are very commonly used and which are very important in unsupervised learning. Okay, it's very important, guys, where we can find this unsupervised learning very useful. Okay, these are the important terminologies for unsupervised learning. So K means clustering. What is meant by this K means clustering? So the K means clustering is, guys, it's basically a concept of a simple unsupervised learning algorithm that is used to solve clustering problems. The name itself says K means clustering, means we are going to do clustering. So K means clustering is a simple unsupervised learning algorithm that is used to solve clustering problems. Okay. It follows basically a multiple procedure of a classifying of given data. We said it is denoted by number K. K means clustering is denoted by number K, the small k. Okay, which is a fixed beforehand. Which fixed, that's the name. K means clustering. Okay, so is K means classification of clustering. So some will be getting confusion here. So in last session you have said it's a clustering, or now we are saying it's classification. How is that possible? Right? So unsupervised classification algorithm. K means is an unsupervised classification algorithm, guys, which is called as clusterization. The groups means the objects of to create is based on their characteristics. Okay. So this is what is meant by K means clustering, guys, the concept for that. And we are going to go for K nearest neighbor we have seen, which is going to attract which are very nearer to them. Okay, the data points. Now we are going to see is hierarchical clustering. So what is this hierarchical clustering? Right. So hierarchical clustering method, it works by the grouping data into tree of clusters. Okay, it's going to group the data and it's going to give us the hierarchical clusters. Okay, the tree of clusters. This hierarchical clustering begins by treating every data point as a separate cluster. Okay, it's going to do every cluster separate, guys, and it is done by tree of clusters. It's going to give a data as tree of clusters. The next we are going to do is anomaly detection. So what is this anomaly detection? It is generally understood to be the identification of rare items, okay, events or observation which deviate significantly. In this data analysis, that anomaly detection is generally understood to the identification of rare items. So what is this anomaly detection used for? Anomaly detection aims at finding unexpected or rare events in data streams. Okay. This anomaly detection aims at finding unexpected or rare events in data streams, commonly referred as anomalous events. Okay. So what is this anomaly detection? It's a detection in generally, basically, guys, I can say identification. Just keep that in mind. Use it for identification purpose. Okay. What is this neural networks? The name itself says neural, guys. So try to remember what it's saying. artificial neural networks. Okay, usually simply called as neural networks. Okay, don't have to confuse there. Artificial neural networks and neural networks both are same. Okay, so artificial neural networks usually and simply called as neural networks or neural nets or computing systems inspired by biological neural networks that constitute animal brains. Okay, as ANN is based on collection of connected units or nodes called artificial neurons. Okay, basically like this, guys. For what these neural networks are used for? Why it is too much of important of neural network? Neural networks can help computers make intelligent tests, means make intelligent decisions with limited human assistance. Okay, these neural networks can be help computers to make intelligent decisions with limited human assistance. So, if you want to make any decision, it's gonna go with limited human assistance. Okay, this is because uh, they can learn and model the relationship between input and output that are non-linear complex. Okay. So what is neural network? So explain me in brief. Neural networks, also known as artificial neural networks, ANNs, okay, are simulated neural networks. Okay, so let me write it down for you. Is nothing but as ANNs, artificial neural networks, or SNNs. Okay, which is known as simulated neural networks. It is a subset of machine learning and are the heart of deep learning algorithms. These are the heart of deep learning algorithms, guys. Okay, so their name, the structure are inspired by human brains itself. That biological neurons signal to one another. So we know that, right? The neurons signal one and each other. So the same thing we're going to do in neural networks. Okay. So what is meant by this principal component analysis? The short form of this is, guys, PCA. Okay, what is meant by this principal component analysis? So, principal component analysis is the process of computing principal components and using them to perform a change on the basis of data. What do you mean by PCA? Nothing but principal component analysis, guys, is a statistical procedure that allows you to summarize the information content in large data tables by means a smaller set of summary indices or more easy to visualize. Okay. So this PCA plays a very important role, guys. Okay, in summary indices. So what is this independent component analysis? They both are same, guys, principle almost in the terminologies. So I'm gonna explain in the practical way. So next we're gonna see is what is meant by a priori. What is an a priori algorithm? Sir? The name itself says algorithm. So this a priori algorithm refers to an algorithm that is used in mining frequent products, sets, and relevant association rules. Okay, a priori algorithm refers to an algorithm that is used in mining frequent products, sets, and relevant association rules. Okay, so we have seen what is this a priori algorithm, and the next thing we are going to see is what is meant by SVD. Okay, so SVD is nothing but singular value decomposition, guys. The name, the short name. It is a linear algebra. Is a factorization of a real or complex matrix. Okay, in linear algebra, a singular value decomposition is a factorization of real or complex matrix. Okay, so this was all about some popular unsupervised learning algorithms and their explanation. Okay, so we'll move on, guys. Let's see what are the important topics we have to cover today. So see the unsupervised learning. We have seen how this works, right? So unsupervised learning, We are going to give training data and we are going to send the historical data. So after getting the historical data, okay, let me write it down. So the historical data, it's going to send it to the machine learning. So machine learning is going to learn some patterns equation and it's going to run to the rules or patterns. Okay. So prediction. What about prediction? For training, we're going to set historical data and machine learning and it's going to do some rules and patterns. So what about this prediction? It's going to go to the new data and it's going to send to the prediction. Now to send it to the prediction, we have predicted outcome and it's going to send to the rules and patterns. Okay. In unsupervised learning, the machine is same thing as, but it's going to give importance. Okay. So moving on, we are going to see what is this unsupervised learning. So the last thing you can see here, guys, before going to that, I want to show you this example. So we have input raw data, which are unlabeled data, where we have cats and dogs, guys. Okay. So how to separate them? Well, this is unlabeled data. I want to separate cats and dogs. So what you are going to do? You're going to do some interpretation processing and you're going to use some algorithms and you're going to separate this cat and dog as output. So this is unsupervised learning. Okay. How to input raw data, how to segregate that. Okay. So we'll move on with some diagrams as we saw. So this is unlabeled data, guys. Okay. So you can see what is here the unlabeled data. The unlabeled data, after applying k-means, it has been segregated to green, red, and blue. And X as centroid. So this k-means clustering, guys. It's gonna take the data points and it is gonna give some new value, new labeled data. After that, it's gonna go and give to the average. That average point is the new data. Okay. So this is about unsupervised learning. Okay, so move on. We're gonna see what is this k-means clustering, right? So what is this k-means clustering? So k-means is one search unsupervised learning. We have seen the method that aims to group similar data points in clusters. Of course, at this, so we have seen how it's gonna cluster, and it's gonna group the data sets which are similar to or equal to them. So let me say there is A, B, and C, A. It's gonna give the cluster as A, and it's gonna give as B. It's gonna give as C. Okay, this one data set, this one data set. The name itself says k-means is one unsupervised learning method that aims to group similar data points in clusters, which is similar data points in clusters. Okay, it allows us to cluster about the data in different groups, and it's going to convenient way to discover categories of groups, the unlabeled data set, and its need for training of anything. Okay, it is a centroid-based algorithm, guys, where each cluster is associated with a centroid. The main aim of this algorithm is to minimize the sum of distance between the data point and their corresponding clusters. As I said, guys, when the new cluster is formed, we are going to see what is the distance of that. Okay, it is centroid based on algorithm, basically, where each cluster is associated, with centroid. The main aim of this algorithm is to minimize the sum of distance between the data point and their corresponding clusters. Okay, so how we are going to use this k-means clustering? So this k-means clustering, we are going to see what is the importance of that. What is the importance of based on algorithm? Okay, so how we are going to imply that? So we are going to see that. Okay, so we have seen what is meant by k-means clustering, right? We are going to see how we are going to implement that. Okay, so moving on, guys. Let's move on. We are going to see what are the important topics on the next thing. Okay. So the next slide, we're going to see how these steps are involved for this clustering. What are the steps which are involved there? Okay. So you can expect some steps, right, which should be involved. So we are gonna initialize centroids of K. We are gonna initialize centroids of K for each sample in the set of samples. Assign sample its closest cluster K based on Euclidean distance. So there is one data point and one more data point. So what is the distance? How we are going to implement any distance formula, guys? So we are going to use Euclidean distance. So what is meant by this Euclidean distance? It's nothing but between centroid value and observed value. Between centroid and observed value. Okay. So after that, giving this Euclidean distance for each clusters in the set of clusters means we are going to recalculate the centroid based on the sample of the cluster. As I said, guys. So when there are two data points, we are going to calculate the distance here and new data set is formed. For this data set, we are going to calculate the when the new data set is formed. Okay. So as we have seen, what are the different type of data sets we have, and we have seen what are the important topics, right? So we'll move on now. We'll move on like what is the fourth step? We're going to repeat steps 2, 3 until the stopping criteria is fulfilled. So each time we're going to find a data set, and each time we are going to do the Euclidean distance, and each time we are going to see the clusters and we're going to calculate the centroids. Okay, till when we are going to do that? Till at certain point the K-means cluster has met this criteria. Till K-means cluster has met this criteria, we are going to do this clustering. Okay, so after that, one data point we have got. So after that, what we are going to do? So we are going to go for how to determine the variance of each cluster and sum. So we are going to see how to determine the variance of each cluster. And after everything is done, we are going to repeat steps 1 to 5 with different initialization centroid positions. Okay. After that, we are going to repeat all the steps with 1 to 5 of different initializations of every centroid positions. Okay. So I assume the steps involved in K-means is clear. So we'll move on. So somewhere asking me, what are the advantages, sir? What are the disadvantages, sir? Right? So this is the answer for it. What are the advantages of K-means clustering? The K-means clustering algorithm is used to group unlabeled data. We know that, and it's going to intense into clusters based on similar attributes. We know that, right? So the K-means clustering algorithm is used to group unlabeled data, and we're going to set instances to clusters based on similar attributes. So K-means is the most used clustering method, guys. We're going to go for any clustering method. Everyone is going to go for K-means clustering. Why? Because it's going to give computation is very inexpensive. The computational cost is very inexpensive. And it can scale well with large data. If we have a large data, it can scale very good. It is an appropriate method when you know the number of clusters to be drawn from the data set. So guys, when you know the data sets in appropriate method, it is the number of clusters you can draw from a cluster or from a data set. And the speed, of course, speed of this K-means clustering is faster than K. Okay, so the K-means cluster is an algorithm which is used to group unlabeled data, set instances to clusters based on similar attributes. And the next thing we have is can scale large data, and it is an appropriate method when you have the number of clusters to be drawn. We can use this data set, and the speed of this data set is very fast. Okay, so I'll assume that is clear. We'll move on, guys. We're gonna see what are the remaining steps we have to follow. So, what are the limitations for this? So just keeping on going. So this can do that. This can do that. So what are the limitations? Number of clusters must be chosen. The number of chosen. So let me say a two. Like let me say a two things is given, but number of clusters must be chosen in upfront where we can use them. So outliers can have strong influence on the results. Okay, this will be a problem, guys. Okay. Outliers can have a strong influence in this result. Initial centroid positions have a strong influence on results. Okay. Initially, the centroid positions have very good influences. Okay, which has very good influence on these results. Okay. And the next thing, guys, you can see we have does not cluster well with clustering of various sizes and density. This thing you should be worried about, guys, because it's very hard to work for. Okay. So what is meant by that? So when k-means clustering, cluster is formed, it varies the sizes, right? And sometimes the vary of the size. So for your example, there is 100 to one column and 180 one column. If this is matched on a row, see the difference. Sometimes the same thing may happen with this. It's not going to cluster well, varying data sets and densities. Okay, so that were the limitations. So moving on, what is this k-means clustering? Okay, what is this k-means clustering? Key concepts. For stability running, the k-means clustering is multiple time called as iterations with different random chosen on k values. This will address the multiple local minimum values. So for stability run, the k-means clustering multiple called as iterations. It's going to go with different random values chosen k values. This will address the multiple local machine values too. Okay. So a data point might keep oscillating between two clusters in each time of the rows. And they're going to go with address like by choosing convergence criteria and the number of iterations. Okay. So basically, guys, a data point will always be oscillating on the system. Okay. So after that, the two clusters, it's going to go for a loop and it's going to convergence criteria and it's going to go for maximum number of iterations. Okay, and as you will discuss here, so we have seen what is this centroid set, and we're going to see how to compare between cluster variation within cluster variation. How to compare that we're going to see, and we're going to see typical objective function used on SSC, means nothing but sum of square derivatives. Okay, we're going to see how to implement typical objective functions. Okay, so these are concepts which are very important, guys. Okay, so the k-means clustering concept, if you don't know, I recommend you to see these videos, which are very important. Okay, so after that, we are going to see the key concept we have seen. We're going to see how to implement this. So use case, I'm going to show you the practical way. So this is our graph, guys. Okay, this is our graph which we have got where we have the k-means clustering segregation of that. Okay, and let me show you the elbow curve. So this is an elbow curve, guys. See, you know how our elbow looks like, right? I mean, it's not straight. The elbow curve we call it. And what is the number of clusters we have in there? And what is the thing we have to do here? We have number of clusters from 7,812. So why it is showing 10? So the important thing here is we're going to see the total within. We're going to see what is the total within the, and we're going to calculate the number of clusters in the algorithm. Okay. So this is how I have got a graph that's okay. This is how should you get when you have done K means cluster. Okay, so sorry for that. Let me write it down neatly. So this is for K means clustering which I have got. Okay. So I'm going to show you practical guys. So I think the slides are done with. So thank you for that guys. Means the practical. The theoretical we have seen. We're going to see what is practical. Okay. So as we have seen, I have shown you in what we say spider, right? So today I'm going to show you with Google Colab how to use this Google Colab. What is the difference between the spider and Google Colab? Okay, so not get confused. There are some ideas what is meant by that. Okay, so this is called as Jupyter guys. Okay, I'm going to show you Google Colab too. But now let's concentrate on Jupyter. So you can see robotics of K-means. Okay. So here we have everything guys. So what all the data set is required for K-means clustering. Okay. So in this Jupyter notebook, this is called as Jupyter guys. Okay. For this, we have to download Anaconda navigation. So what is this Anaconda navigation? Okay. So you are download, you can watch always the recorded videos from 360DigiTMG. Okay. So how to import pandas? Okay. So this is a library, guys. Panda is a library. Panda is a library, guys, for data visualizations. From sklearn.datasets, we are gonna import load.digits. So load underscore digits. The name itself says 0, 1, 2 means the digits. Okay. So I have loaded that. Okay. The last time it came, we have seen the surfaces. So it's gonna say it's gonna go on the tiles 4, or it's gonna go on with sand road, or it's gonna go on with the other ones. Right? So here we are gonna segregate using digits. So as I said, this is a Jupyter guys. Okay, so let me show you how spider looks in case if you have attended. So I don't want you to go for that. So this is spider anaconda guys, where you can run the program here on the screen. That is completely fine. We can see spider version 5. If you want to download it, guys, you can go and watch the CEO of 360DigiTMG, Bharati Kumar Deepu, sir's video. So sir has explained how to download anaconda and spider and everything. Okay. So this is the spider, guys. Okay. So I want just to show you in case if you are mistaken, and that is nothing but a spider where you can run the code multiple times, where we can import libraries as NP or PA plot. Okay. So in Jupyter Labs, we're going to see how to import the libraries. Okay. We have imported the libraries with digits. We are going to load underscore digits. And after that, in the digits target, forgive, okay, forgive digit targets, you can see array, we have got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Till 8 we have got. Okay. So I'm gonna use digits. So here, the future names or the names or the targets, so everything we are gonna use here, guys. Okay. So I'm going to see how to use digit target names. So here the array The array gives us the digits that's 0, 1, 2, 3, and everything. Okay. So this is my data frame. So df.head. Why is this df.head is used for? df.head, guys, where basically I can say which gives us the first 5 rows. Okay. So in Python, if I say uh, any name like Vikas, it starts from 0, guys. 0, 1, 2, 3, and it doesn't start with 1, 2, 3, 4. Okay. Python always starts with the number 0. Okay. So do mind that, guys. Okay. So this is all about this. Okay. How this Python this one works. Okay. So in the output.head, if df.head, it's going to give first 5 rows. Okay. So after that is done, we are going to see what is a target. Okay. So what is target used for? Okay. So we're going to see why is target head.20. You can see the digit. Okay. So why is this important? df.target. It's going to go for digits.target, and we are going to see df.head where we have 20 data sets. Okay, I have said 20. You can see we have 9 rows. So 0 to 9 and 0 to 9, the 20 data set rows. Okay, so df.head gives 5, df.head 20 gives 20. You can see what are the data sets targets.digit. You can see so what are the combinations we have used. Okay, so after that, we are going to import selection of trains, test, and split. From sklearn.model, selection import train, test, split. You're going to test and train. You're going to split is train and test. X train, X test, Y train, and Y test. So we have seen what is meant by this X train and X test, right? So it is nothing but where we can use this unsupervised learning. Means we know if the model is and train is and test is high, it's a right fit model. Okay, if train is high and test is high, it's a right fit model. Okay, train, test. If train is high and test is low, it's called as we know it is overfitting or variance. And if both train and test are low, we have called as underfitting or bias. Okay. So how to solve this high and low? We are going to use a method called regularization, which fits data into a model to avoid overfitting. For underfitting and bias, we are going to transform the data or do EDA. Okay. So this is thing of train and test and split, guys. I have used both train and test and by train and by test. From sklearn.labels, I'm gonna go with k neighbor classifier. So we are doing k-means clustering. So I'm gonna use the classifier as 5. So the length of the exchange which we have sent for the data to understand, it is gonna give us 1257, the exchange. And the length of the X test is 540. Okay. So knn dot fit of X train dot Y train. It's a k nearest neighbors classifier. Okay. So I'm gonna use a fit function there, guys, where it can fit with X train and Y train. Okay. And after that, I'm gonna go with knn dot score. So what is the score I got from my X test and Y test? So you basically able to understood now what is meant by train split and test split, right? So why we are doing that too. And I'm going to go with knn dot score where we have X train and Y train. This neighbors classifier. Okay. We are going to go with 0.987. This is the accuracy which we have got for knn dot score. Okay, the score for X test and Y test here, guys. So you can see what all the packages, the libraries I have used, what is the data set for this k-means clustering. We have got the output as this. Okay, and here you can see have write a thing with comment, guys. Okay, here you can, so let me clear that for you. So you can see I tried various values of k-means. So for my understanding, so if you don't give any hash symbol, guys, it is considered as a code. If we give as symbol, then it is a comment. Okay. So my comment is, for my understanding, when I was doing k-means clustering, I have given k manually, where k is to 5, giving me the best score. Okay. So from sklearn.metrics, I'm going to import confusion matrix. So what is meant by confusion matrix? Guys, is very important. What is meant by confusion matrix? So confusion matrix is nothing but is a table that is used to define performance of classification of the, as we know, we are going to do classification here. So we are going to use confusion matrix. So confusion matrix is used for classifications. Okay. So after using confusion matrix, we are going to go for how to predict Y test, how to use X test. Okay. So after applying this confusion matrix, so we are going to knn dot predict. We're going to predict the test, and after that, we're going to apply confusion matrix. Okay. So after confusion matrix, you can see we have got Y test and Y prediction. Okay. So I have implemented confusion matrix to get the result. So after applying that, we have got the array. So the array is what you have seen. So you can see the diagonal things, it is different. So this is the output which we have got for confusion matrix. Okay. So after that, I'm gonna go for matplotlib. Okay. So the matplotlib, I'm gonna import matplotlib.py plot as plt. Okay. So I'm gonna use it for graphical representations. Okay. So the matplotlib is used for graphical representation, guys, and cbol is for advanced data visualizations. Okay. So we are going to import this both to predict the labels which we have got for the output. Okay. So after importing matplotlib as plt and import cbol as sn, so we know this both matplotlib and cbol is nothing but a library space. Okay. Where pandas is it for data visualization. In the starting line I have said. So after that, I'm going to go for a heat map. Okay, this is called as heat map. Okay, so I'm going to go for SN. So advanced data visualization. Here you can see I'm importing CBOL, this advanced visualization, and using SN as heat map for advanced visualization. Okay, so after using the heat map, I have got a map like this for my robotics analytics using this k-means cluster. Okay, and you can see the X label we have got predicted, and the Y label we have got, okay, Y and X. So we have got what is the predicted thing and what is the truth thing. Okay. So you can see the text 42.0.0.5 are the truth. Okay. So this is a diagonal element. We are using confusion matrix, and we have imported some libraries as C1 for advanced data visualizations, and we have done. After predicting the truth and predicted, we are going to go for the things which is the accuracy what we have got. So I'm going to input classification report. Okay. So I'm going to do a classification thing, guys. So I'm going to import from sklearn.metrics. I'm going to import classification report to classify, guys. So in K means we are going to do classification. Okay. For Q means we are going to use classification. So let me write it down properly. So for K means we are going to use classification. Okay, so here for that I'm gonna go for with sklearn.metrics. I'm gonna import classification report. So after importing this classification report, I'm going to print classification report, y underscore test and y underscore prediction. Okay, the test data and prediction data. So after applying these things, I have got to the precision. Okay, recall, F1 score, and support. So what is the accuracy which I have got by this k-means clustering? Okay, the accuracy and the macro average and the weighted average. So what I have got using this k-means clustering, using this classification, confusion matrix, and all the libraries used for this k-means clustering. So we have got the accuracy and the weighted average. So here you can see what is the support and what is the accuracy, right? So how we are going to do classification. Okay, this is how we are going to do classification of k-means cluster. So that's all for today, guys. So in the day 1, day 2, day 3, we have seen how to work on. So how to understand the concepts we have seen. On day 4, we have seen how we are going to implement K and so today we have seen how to implement K-means. So in case if you have missed any session, guys, you can go and watch the recorded videos always about this robotics. Okay, where you have some interest and you can do some researches on what data set I have worked on. Okay, so thank you for attending today's session, guys. So okay.